Hello, I'm Juan Carlos Gonzalez, and today I'm going to explain this circuit. First, I'm going to name the currents and the meshes. Okay, so I start with mesh 1. Oh, I forgot to say here, there's a super mesh. I1 will be minus 5 because it enters from the negative side, plus 30 because it only shares a current with itself, it's only I1. But 45 shares two currents, so it will be I1 because we're analyzing mesh 1, and I2 negative because it shares. This will be simplified as 75 I1 minus 45 I2 equals 5. Second mesh. Here the current enters from the positive to the negative, so it will be positive. So we have 7 plus 54 I2, and because we're analyzing I2, I3 is going to be negative because the resistance is shared with I3. And here I made a mistake. It's not shared with I2, it is shared with I3, as we can see here. After that, we have another equation simplified. It would be I2 plus minus 54 I3 equals minus 7. Then we have the super mesh 3 and 4. And because here we can see that I3 is exiting the current and I4 is entering the current, I4 is going to be positive and I3 is going to be negative. I4 minus I3 equals 1/4. And then we do the border equations, which are these ones. We do first the one that is shared with I1, and because we're analyzing the super mesh, it will be subtracting I1. 5 I1 plus 54 I3. Same case here. We will be subtracting I2. And here we go, because 4 is alone, we use it alone, and it's an I4, so it will be I4 equals 0. Here we simplify it again, minus 45 I1 plus 54 I3, I2, minus, plus 99 I3, and plus 4 I4 equals 0. Here we have our equations, and we are going to compute on a program, which is called, which the teacher recommended us. It's called Wolfram Alpha. So here we have that. We're gonna use A as I1, and B as I2, C as I3, and I4 as D. So we just compute it here. D minus 54C equals minus 7. And we compute 1 minus, no, sorry, D minus B minus C, equals 1/4. And then we have minus 45A minus 54B plus 99C plus 4B equals 0. Then we get that I1 is going to be minus 23 over 330. I2 is going to be minus 106 over 297. I3 is going to be minus 5 over 22. I4 is going to be 1 over 44. And we want to know Vx. The voltage is equal to the resistance time its current. Here, the resistance is being shared with these two. But because we know that here our I1 is entering and I3 is entering towards the negative, I1 is going to be positive and I3 is going to be negative. So we use voltage is equal to, resistance is 45 times I1, which is going to be minus 23,330 minus 5 over 22. We can put these on our calculator, and this will be 45 times minus 23 over 330 minus 5 over 22. This is equal to 7.09 volts. That's Vx. And for the power, because these two are in parallel, we have to get the voltage from this one, which is going to be voltage at the same is equal to Ri, because power is equal to IB. So here we get the voltage, and it's going to be 4 times 1 over 44. And the power is going to be 1/4 current. It's the magnitude of the power times 4 times 1/44. These ones are going to cancel, and the magnitude of the power of the current is going to be 144 watts. Thank you.